Welcome to Information Technology, to the new chapter E-commerce with a focus on analytics. Let's do a brief repetition from last week. We talked about e-commerce and e-business. We have looked at different ways to create revenue and create business models. And we talked about two models, namely the transaction costs and the 5 forces by Porter, to show that e-commerce simply has an influence on commerce. This week we talk about e-analytics. So the question how Google and Co. are able to track what we are doing in the internet. We're talking about structure of websites. We have a look at the protocol, how a client accesses information from the web server, and we have a look on cookies. The next week we will have a look how e-marketing is using this kind of information to provide personalized feedback and how to do e-marketing controlling, so to have a better overview which of the advertisement is working good and which is not. In the internet, advertisements are personalized. Probably you have experienced that you see other advertisements on a web page compared to your friends or whoever. And most often the ads are quite well suited to fit to your needs. Maybe you have even experienced a situation like the following. You are looking, for example, for a pair of shoes in a web shop. So you're going around, clicking on this web page, on another web page, have a look from the front and on the price, and suddenly you decide not to buy them. You continue surfing somewhere else, and suddenly an ad shows up and presenting and offering the shoes 10 euros cheaper. Maybe the offer even comes from another web shop. How does this second web shop know that you have been interested in these shoes? Or generally speaking, how are we tracked in the internet? To explain how we are tracked, the terms customer journey and touch points are necessary to be explained. So what is a customer journey? A customer journey is the collection of all touch points during a sales process between a customer and a product or a brand. And what is a touch point? So always when a customer gets into touch with a product, a service or a customer, that's a touch point. And we use this term sale in a broader sense. It's not only the exchange of money against a product. It starts when a customer gets aware of a new product, when he's doing research, when he talks about a product with friends, and it continues after the exchange of money against the product, for example, when the dealer asks for a satisfaction level of the customer. Let's have a look on an example. Mary sees a TV ad and is interested in a BMW touchpoint. She talks to a friend and talks about the car touchpoint. She surfs in the internet to do some research about this BMW touchpoint. She goes to her local BMW dealer touchpoint. Later the dealer calls Mary touchpoint. The story continues. Mary buys a BMW at another dealer touchpoint. BMW, not the dealer itself, checks by email if everything is fine touchpoint. The story continues. All these touch points together, all these touch points belonging to one person and one product, they are called the customer journey. If you go through the internet and if you Google for images about customer journey, you will find different images, but they're all quite similar to the one you see here. Typically, a customer journey is built up out of phases. So you start, for example, with awareness and you end up with advocacy. However, the number of phases and the name of the phases differ by model. The touch points are points. What you can see here is that touch points can be online and offline. For example, radio or TV, that's probably offline, whereas reading a blog or surfing on a website, that's clearly online. And what you can see as well, it's not only this purchase phase in the very middle where you do the exchange of money against product, it starts way before and ends after this phase. So now have a look on how the access and the tracking is really done. To understand that, we have to have a closer look how a browser, how a client accesses a web server. Actually, a GET request is sent from the client to the web server. This term GET is really sent as a word over the internet, at least if you use this HTTP protocol. And as a parameter, the index.html, the name of the web page, is handed to the web server. Now what does the web server do? It checks if the index.html web page is available and sends this back. In addition, the web server protocols. He recorded each access into a log file. This is a really long log file, and there is a single line for each access, for each GET request to its web server. So what does this line contain? There is some information you can see here, but this will be explained better on the next page. Actually, it is exactly the same information in the second column, where you have this value in example. In the first column, you see how this field is entitled, and in the third column, you see an explanation. So the first value is the IP address of the client. By that, the web server simply knows who is contacting you. The next two parameters are unused. Originally, they have been thought for identifying a user, but it never really has been chosen as an option in here. The fourth parameter is the timestamp. So you can see this GET request has been sent on 18th of March 2003 at a given time. And the next parameter is actually what is asked for. So here it could be logo.jpg, a JPEG file in the image directory, and it's requested using the protocol HTTP version 1.1. Then there is a status code. The status code in this case is 200, which means the GET request has been successfully answered. Maybe you have seen this status code 404, which is always sent back if you have requested a page which does not exist on the server. The next parameter is the amount of bytes sent back. In this case, it's for 512 bytes. Now, the last two parameters are of interest. So the first one is from which site is a client coming. In this case, you can see it's www.wikipedia.org. So maybe there has been a link from Wikipedia to the page the request has been sent to. This could be interesting. So for example, if the site is Google, then maybe somebody asked for your company or for your product and it has been shown in the Google. Or he or she has clicked on an advertisement and this advertisement has been displayed and clicked on by the user who has sent this GET request. Finally, you see what it's called a device string. So you see, first part is Mozilla, which means probably it's a Firefox browser. The second part is a Windows system, which is X11 in here. It's the operating system Linux. It is something with the hardware i686. A chosen language is displayed DE minus DE and a revision. Based on this kind of string, you can derive which kind of hardware is used. For example, in this case, a Linux operating system, probably on a laptop or a computer. The device string for a smartphone would be different, and by this kind of information you simply know if somebody is using, for example, a smartphone or a laptop, if he or she is using iOS or Windows, and things like that. Which information can now be derived from the log file if you have several entries with GET accesses? So first, the IP address. Actually, in this state, it's not that much of value because a user cannot be identified with the IP only. As you might remember, IPs are usually assigned to a computer once it goes into a new network, and it of course could be that several users might use the same computer with the same IP address. So you cannot really detect the person simply by IP. However, if a person is for a certain time surfing in the same network, the IP address is fixed. And now you can see if the user is accessing several pages from the same web server, that it's always the same user. Being there, it's called a session, and you can see during a session which pages user is turning to, how long it stays on which page, etc., etc. You can see from which website the access, the request comes. Where has the user been before? If you come from a Google, you can, for example, see for which terms users are looking for and under which terms you are found in the internet. If the user comes from another website, it could be by ads, so you can see which of your ads are working well and which do not. And if it's an internal link, so a link from within your website, you can see how the users are surfing through your web shop. Are they actually going the way you would like them to go? Are they maybe taking short paths and not passing by those parts you would like them to go? Which hardware and browser is used? So if most of your users are coming by smartphone, have you really optimized your web shop for a smartphone? Do you have, for example, responsive design so that smartphones are supported at all? Based on this information given on the former page, statistics and key figures can be derived, which is important for controlling. So, how big is the number of impressions, meaning the number of pages displayed? How is the number of impressions per day? What is the relation between smartphone and computers? Can you determine a return rate, at least based on the IP addresses? How long do people stay on your website? Do you have a bounce rate? A bounce here means somebody gets into a web page and directly goes back because it's not what he was expecting. You can do measurements of your marketing means. For example, display ads, or how good is your search engine optimization doing. These are things which can be done. In addition, you can check the quality of your own website. Where do the customers land? We call it the landing page. Are they actually landing where you want them to land? Which web pages are visited and which pages are not? Do customers reach those areas you want them to go? And do the customers buy? You can by click observe if somebody puts some products into a cart, goes to the cashier, starts to pay, and then suddenly he stops and disappears. So where is actually the point the customers do not continue? How long do the customers stay on each page? Is the page attractive enough, or are again the customers bouncing back? This is important information when you design your web shop, and just compare it to a physical shop. If you would like to get figures and observations like the above, it would really take lots of effort and resources to get this data. And in the internet, you get it simply for free. That makes this internet and the web shop really a source for much information about customers. Let's have a look on the customer journey and our touch points. Looking on this log file, what kind of information can be derived? Which touch points can be identified? First, of course, only those which are online. However, second, only the ones on your own website. So if, for example, online ads are displayed somewhere else, you will not find out if a customer goes there. Only if a customer clicks on the ad and is then forwarded to your website, you might know. So you see, it's at the very moment only a limited information. However, it's information important to design and redesign your web shop. To go in more detail, we have to have a closer look on how HTML pages are built up. What you can see down here is a web page, a part of a web page written in the language HTML. If you have a closer look, you see points where, for example, href equal to stylesheet.css, or where we have dyname.js or logo.jpg. What does it mean? Actually, the web page contains information about other parts, about images and scripts which have to be loaded after the HTML page has been loaded. So a web page is not a monolithic block. It's something which points on more components which have to be requested later on from the web server. So let's again have a look on the communication between client and web server. The client sends a GET request asking for webpage.html to the web server, and the web server delivers this web page to the client. Now the browser checks the content of the HTML and sees that there is components which have to be requested for. For example, this stylesheet.css, it's again another request sent to the web server, and the style sheet is delivered. And next, the script.js, and again the script is delivered. And finally, this image logo.jpg, and logo.jpg is delivered. In this case, actually, we have had 4 GET requests. Now that's not interesting at the very beginning, but things can become more complex. Because the components do not have to be stored on the same web server. They could be stored on different web servers. So it could be that once again we ask for the web page, and web server 1 gives our web page back. However, the script is stored on web page 2, and the script is sent back, and the image is stored on web server 3, and the web server 3 is giving the logo back. Now this is important, as the user sitting in front of the browser has only clicked on webpage.html. However, due to the structure of this HTML page, some more web servers have been contacted, and these web servers can now store these kind of GET requests in their log files as well. HTML pages usually are composed of many components. There is this datenblumen.wired.de web page where you can compose these what is called data flowers, Datenblumen. In here I have accessed a page on spiegel.de. Each of these bubbles stands for one GET request. You see different colors, so actually the green part is HTML, the orange part is a CSS, and there's many pictures which are in this blue. And what you can see, there's most of these images located on spiegel.de, but you can see some more outside of this spiegel.de circle. For example, you can identify edition.com. Now, edition.com is a typical company which creates profile of different users. There is not only edition.com, there is Facebook and Google and the others who all are interested where you are surfing. So let's again have a look on a some more complex situation. Now the client is surfing. The client first requests a web page from spiegel.de. He gets it. On this page there is a component by edition.com. He asks for this component and he gets it. So edition.com does know that the user has been on spiegel.de. Now the user surfs to the next web page, let's say to gmx.de. He sends another GET request, he gets another web page, and on this gmx.de there is again a component by edition.com. So a GET request is sent and the ad is sent back. Now what has happened? Spiegel.de knows that the user has requested something from Spiegel.de, and gmx.de knows that the user has been on gmx.de websites. However, edition.com knows both Spiegel.de and gmx.de. He knows where the user was surfing. And this is actually interesting to create a profile. Edition.com is now setting up networks of lots of websites. Let's have a look how it works. You can see the customer down in the upper left corner. And you can see the network of different websites circled with this red circle. This network is organized by edition.com. Actually, the web shop, which is in the upper left corner, is part of this network as well, but to not make this picture too unreadable, we have taken it out of this red circle. So now this communication go. The user surfs in the internet, and as on each of these websites there is some kind of component by edition.com. Edition.com gets informed and delivers this component. By that, edition.com gets lots of information about the user and can create customer profiles. Now the user would like to go to the web shop which is part of edition.com's network. He surfs there and the web shop realizes an ad should be placed to announce some kind of product. The web shop now informs edition.com, and edition.com checks, okay, I know this customer, I have a profile, which ad suits best. This ad is selected and then displayed on these on the browser of the computer. The user has not consciously been on the website from edition.com. Still, edition.com knows lots about it. It has created blog files and created a profile from this user. So Addition.com knows on which page the user has been, how long, if he compared different products, and so on. A big amount of data now is produced and analyzed. And important, this information does not come from one single web server, but from several different servers. So user profiles can be created based on the information from lots of different web servers. And by that, personalized advertisements can be distributed and selected. Problem? We still cannot assign this IP address to an individual person. Again, let's have a look on our customer journey. So, which touchpoints can now be identified? The difference compared to the situation we have had before is now that we can now track touchpoints on several websites. So probably if you have a good network, then you can have touchpoints in all phases, from awareness to advocacy. Still, we face a problem that we only see one IP address and can connect IP touchpoints to IP addresses during a certain sessions. So what we can see right now is sessions in different phases, and we cannot at the moment compose a complete customer journey out of it. So that's what we are looking for in the next chapter. Do you know cookies? I guess you have experienced cookies, but maybe you do not know how they work and how they support the tracking of people. The communication in the web, that means the HTTP protocol, is what computer scientists call memoryless. That means the HTTP protocol has been designed in a very simple way. The protocol can simply send information forth and back, but it cannot store information about this former communication. For example, if you have logged into a website, the communication protocol doesn't remember. Or if you are in a web shop and you have put things in a cart, then the protocol doesn't remember which things are in a cart. It's not part of the protocol. To overcome this problem, cookies have been developed. Cookies are small files which are stored on the client on behalf of the server. If a client sends a GET request to a server, it first checks if there is a cookie stored from the server. In case there is a cookie, then the cookie is sent back together with a GET request. Usually, the cookie just contains an idea. The idea is unique, so it's something like a passport, where people or users can be identified. The web server is now able to identify which ID has been sent. And if, for example, something has been placed in the cart before, then the web server now can remember, not the protocol, but the web server can remember that there was something in the cart, and it can see it by seeing this cookie and this ID. Important, the cookie is not a program. It cannot be executed. Thus, it cannot harm the computer. It's not a virus, something like that. However, cookie makes it possible to identify and track people, to identify which user is here and has been on this web page before. Let's have a look on the communication between the client and, in this case, the server by Amazon. Let's assume the client turns to Amazon the first time. So simply a GET request is sent. Amazon checks there is no cookie sent, so Amazon now in its answer adds an additional cookie. This cookie is stored at the client side. And when the next time the next request is sent, the cookie is put on top. This is done even if the IP address has changed in between. So now, for tracking if a certain person is coming back again. Not the IP is used, however the cookie. So Amazon answers with page 2, and again it puts a cookie on top. And if something is placed in the cart, again the cookie is put on this request, and now Amazon can remember, hey, I know this person, it's identified by the cookie, and the Amazon server has stored which products have been placed in the cart and can design the web page accordingly. So Amazon does not only forward web pages, but it forwards again these cookies, which are now used as a way to identify the client towards the Amazon server. I already argued that there's lots of components within web pages. So sometimes these components are very small. They're sometimes just 1 pixel. In this picture you can see that there is 1 × 1 pixel images, and the color of these pixels is transparent, so you can't even see it. And these pixels are simply placed there to enable some companies like Edition.com to place a cookie as well. So if the pixel is placed there and is requested then from, for example, Edition.com, Edition.com will be enabled to place a cookie on your computer as well. This is sometimes called a tracking pixel, and the process is called pixel tracking, and you can have a look on the details, for example, in Wikipedia. Of course, you can switch off cookies, but what is the consequence? Actually, you could switch off cookies completely or just for individual websites. However, again, what is the consequence? You would not be possible to log in somewhere. So if you log into Elias and have switched the cookies off, Elias won't remember that you are logged in. So you will always ask again to first log in. Same for Facebook or GMX. Or if you go into a web shop and you would like to buy something and place something in a cart, this will always be forgotten. Just give it a try. So now having cookies, what kind of information is gained? Actually, we do not get new touch points. However, we are now able to assign all touch points to 1 cookie, and by that to 1 user. So if we have had simply a collection of different kind of touch points, we are now able to compose a customer journey out of these touch points. So this makes touch points and cookies in combination so good for tracking people. Again, suppose you have switched off cookies. Can't you be tracked now? Yes, you can. How is that? If you are requesting a web page from your smartphone and the next time from a desktop, the web page will look differently. Why? We call it responsive design. You always transport information about your hardware and software, and therefore the web server can choose how the web page is layouted when it is given to you. So actually, let's again have a look on our communication, and when we send this GET request, we put some additional information in here. So here, for example, you see our user agent string Mozilla.5.0. You see it's a German web page. You see encoding, we prefer gzip over deflate, and so on and so on. And this information together is like a fingerprint for your computer. There is hardly any computer which is the same as another computer. And this kind of information can be used as an identification even if you have switched off cookies. So again, using this kind of information, a user can be identified even if cookies are switched off. This approach is sometimes called canvas fingerprinting. From a data privacy point of view, it's a little bit a gray zone if this should be supported or not. However, take a look on the following webpage, www.deinipcheck.de. It will display all kind of information which is given from your computer to this web page, and you can see it's really a lot of information, and you can maybe understand that it's enough to distinguish different kind of users. So it's like an idea as well. Let's have a quick summary. We are supervised in the internet. Our behavior in the World Wide Web is supervised on very detailed level. To overcome this surveillance is only possible with effort and cheating. Today's supervision works so well that advertisements for web pages are auctioned in real time. So if you, for example, have clicked on a pair of shoes in Zalando, you are identified as a person who is interested in shoes. Later on, you are surfing to another web page which displays ads. And in the background, now there is an auction going on. And the auction simply goes like this: hey, there is a user who is interested in shoes. How much are you willing to pay to display an ad? And the one who pays more is able to place this ad. This goes in the background, and you will not even notice that an auction has been done. It's all done automatically, all in the background. Let's discuss for a brief moment how marketing and tracking is influenced. We already have seen that there is a conflict in marketing between richness and reach. Have a look at the picture from last week. So you have either a big reach, so you meet many people, but only with a non-rich information. Or you can have a talk, for example, directly an interview with a customer, and you have very rich information, but you have a low reach only because you only reach a single person. Now having e-marketing and being able to track lots of people creating profiles automatically, you can hand out information which is individualized to each person, and you can do it to very many persons. So the conflict between reach and richness, at least to a part, is solved. One more comment to analysis versus analytics. So what is the difference? Actually, there's a gray zone, so there's different kind of definition what analytics is at all. One answer could be the perspective. Analysis has a look in the past. What has happened? Why has something happened? Whereas analytics looks in the future. What will happen most probably? Then it's different kind of methods. Analysis is often decomposing a complex thing into parts and try to understand then these parts. Whereas analytics uses techniques like machine learning or artificial intelligence or pattern matching. It's very often based on computers and algorithms. The goal of web analytics is to understand user behavior. It's the collection and evaluation of user behavior in our web pages. And web analytics aims for an optimization and better performance of websites. So how to get better understanding the number of visits, how to increase this number of visits, how to increase the numbers of impressions, meaning how often things should be displayed. How do we get people to call for action, so to buy something, for example, and so on and so on. We will discuss what these clicks and conversions and impressions are the next week.